Hey guys, we're starting off with 2.1, Precalculus for Mathematics. Let's start off with the definition of a function. A function is f is a rule that assigns to each element x in a set A exactly one element called fx in a set B. This basically means that each x value can only have one y value. We're given the function fx equals x cubed plus 1. This means for any input x, we cube it and then add 1 to get the output. Let's break it down. For part A, we need to find the value of fx when x equals negative 1. To do this, we must plug negative 1 into our function. So this is how we would write it. So then we would do parentheses negative 1 cubed plus 1. And this would equal negative 1 times negative 1, which would be 1. And then 1 times negative 1 again, which is negative 1. So it would be negative 1 plus 1, and that would equal 0. The value of f at x equals negative 1 is 0. Now let's move on to part B. When for x equals 2. Just like before, we substitute 2 for x in our function. F parentheses 2 equals 2 cubed plus 1. 2 cubed would be 2 times 2 times 2, which would be 8. So it would be 8 plus 1 equals 9. So therefore, the value of f at x equals 2 is 9. And there you have it. This function is straightforward to evaluate once you understand how to substitute values into the function expression. We're looking at another interesting function problem. Let's dive right into it. We're given the function fx equals 2 parentheses x minus 1 whole squared. This function represents a quadratic equation where the term parentheses x minus 1 squared indicates a parabola shift 1 unit to the right and then scaled vertically by a factor of 2. Let's evaluate this function at the values of x given in the table: minus 1, 0, 1, 2, and 3. For x minus 1, let's plug in 1 to the equation. So it'd be 2 parentheses 1 minus 1 squared would equal 2 parentheses negative 2 squared, which would equal 2 times 4 equals 8. So f for x value of negative 1, it equals 8. Now let's do 0. So we just plug in 0 again into the equation. So it would be 0 minus 1 whole squared would equal 2 negative 1 squared equals positive 2. So f parentheses 0 would equal 2. Now let's do 1. We do 2 parentheses 1 minus 1 whole squared. This would be equal 2 parentheses 0. So this would equal 2 times 0 is 0. So for x value 1, it would be 0. Now let's do 2. So 2 parentheses 2 minus 1 whole squared would equal 2, 1 whole squared equals to 2. So for x equals 2, the value would be 2 in this function. Lastly, let's do 3. So 2 parentheses 3 minus 1 whole squared would equal to 2 parentheses 2 whole squared, which would equal 2 times 4, and 2 times 4 would be 8. So for x value 3, it would equal 8. As you can see, evaluating this function involves a bit of arithmetic, but follows a clear pattern once you understand the function's structure. The values of fx show how the function changes as x increases, creating a symmetrical pattern for type typical of parabolas. This problem is about evaluating a simple function at different values. Let's get straight into it with our function fx equals x squared minus 6. The task here is straightforward. We need to find the output of the function fx when x is 3, -3, 0, and 1/2. Let's calculate each one step by step. Let's start with f parentheses -3. For this, we would just plug in -3 into the equation. So it would be -3 whole squared minus 6. -3 squared would equal 9, and 9 minus 6 would equal 3. Now let's move on to f parentheses 3. For this, you would do 3 into the equation. So it'd be 3 whole squared minus 6. And this 3 squared would also be 9. So it'd be 9 minus 6, which would equal 3. 3 isn't the same because -3 squared and 3 squared is both 9, because it would cancel out the negative sign. So it would both be a positive value. Now let's do f parentheses 0. Now we just plug in 0 into the equation. 0 squared minus 6. 0 squared would equal 0, obviously, and then minus 6. So 0 minus 6 would equal -6. So for x value 0, it would be -6. Now, lastly, let's do f parentheses 1/2. Sorry. So 1/2 whole squared minus 6. 1/2 whole squared would equal 1/4. And 1/4 minus 6. Now let's change 6 into terms of 1/4. So 1/4 minus 24 over 4, which would equal -23 over 4, which is simplified into -5.75. There you have it. Each value of x gives us a different fx, and by substituting and calculating, we've determined these values precisely. Now let's move on to the next problem. This problem is very similar to the previous one, but this time it uses an absolute value sign. Let's dive into evaluating this function for the given values: -2, -1, 0, 5, x squared, and 1 over x. Let's start with f equals f parentheses -2, I meant. So if you put -2 in the absolute value and -2 below, which would equal -2, would become positive, so it'd be 2 over -2 equaling -1. Now let's move on to x equals -1. We put in now -1 into the absolute value, and we would put -1 down here, which would equal 1 over -1, equaling -1 as well. F equals parentheses 0. Now watch out for this problem. I'll show you why it can be kind of tricky sometimes. We put 0 in the absolute value and 0 below. This function involves division by 0, which is undefined in mathematics. As tempting it is to put in 0 for the answer of this problem, 0 over 0 would not equal 0. It would be undefined. Let's move on to f parentheses 5. 5 would go in the absolute value and 5 would go down below. Since 5 is positive anyways, it would become 5 over 5, which would equal 1. Let's move on to f parentheses x squared. When considering x squared in the function, fx It is important to remember that x squared will always be non-negative because squaring any real number, whether positive or negative, results in a non-negative number. So now let's plug in x squared. Oh shoot, I meant to do it here. Let's do x squared over x squared. This would equal x squared over x squared. And this would simplify to 1. But remember, this would only be possible if x does not equal to 0. Because if x equals 0 on the denominator, x 0 squared would equal 0. And it's not mathematically possible for have the denominator be equal to 0. Now, let's move on to the next part. F parentheses 1 over x. F parentheses 1 over x would equal to 1 over x over 1 over x. Here, the absolute value of 1 over x simply removes any negative sign, resulting in a positive 1 over x if x was negative, and remains 1 over x if x was positive. Now let's do this. So absolute value 1 over x. Shoot, one second. 1 over x, it would become, and 1 over x, which would equal 1 if x was positive, if 1 over x is positive. If otherwise, for the negative version, it would be 1 over x, but bottom would be negative 1 over x, which would all equal negative 1. However, just as you remember, x cannot equal to 0 because in the denominator it would be 1 over 0, which is just not possible mathematically. The function f parentheses 1 over x evaluates to 1 when x is positive and negative 1 when x is negative. Now we're going to learn how to evaluate a piecewise function. This type of function has different rules depending on the input value of x, which makes them super interesting and a bit tricky at times. Let's jump right into our function. Fx equals x squared if x less than 1, and x plus 1 if x is greater than or equal to 0. We're going to evaluate it at the several specific values, negative 2, negative 1, 0, 1, and 2. Let's start off with f equals f parentheses negative 2, excuse me. Since negative 2 is less than less than 0, we would have to use the first equation. So we'd plug in negative 2 into x squared, which would equal 4. Now let's do f parentheses negative 1. Again, negative 1 is less than 0, so we would use the first equation. So we do negative 1 squared equals to 1. Now let's move on to f parentheses 0. Since we would try using the first equation, but it's not possible because 0 is not less than 0. Instead, 0 is greater than or equal to 0. The key word is equal to. So now let's plug in 0 into the second equation. So it'd be 0 plus 1, which would equal 1. Now let's do f parentheses 1. 1 is greater than or equal to 0. So we do second equation. So it'd be 1 plus 1, which would equal to 2. Lastly, let's do f parentheses 2. So f parentheses 2. We'd use the second equation again because 2 is greater than or equal to 0. So we do 2 plus 1, which would equal to 3. We've successfully evaluated the piecewise function at 5 different points. Piecewise functions are handy for describing situations that have different conditions or rules based on input values, making them prevalent in real-world applications. Now, let's move on to the next problem. Okay, we're going to continue to evaluate more functions, but in this time, we're going to use f parentheses x plus 2 and fx plus f parentheses 2. Let's start with f parentheses x plus 2. So let's start with plugging in x plus 2 into the function. So x plus 2 become whole squared plus 1. Let's try simplifying x plus 2. So it'd be x plus 2 times x plus 2. Plus 1. X times x would become x squared. X times 2 would become 2x plus, again, x plus x. 2 times x. So 2x times 2 times 2 plus 4. And then, obviously, plus 1. So this would simplify into x squared plus 4x plus 5. Now, let's move on to fx plus f parentheses 2. Okay, so let's plug in x into the first part. So it would be, again, x squared plus 1. Now we have to do the second part, f parentheses 2. So plus, again, in parentheses for f parentheses 2, 2 squared plus 1. This would simplify to x squared plus 1 plus 4 plus 1, which would in the end simplify to x squared plus 6. Now we're going to find the domain of a function. First off, what is the domain? In mathematics, the domain of a function is a set of all possible input values, or x values, which the function will accept to produce a valid output. Now, let's apply this concept to the function given. Fx equals x plus 2 over x squared minus 1. Let's understand the function. The function is a rational function, meaning it involves a fraction with polynomials in both the numerator and the denominator. First, let's identify the restrictions for a rational function. The domain is all real numbers, except where the denominator is 0, since division by 0 is undefined. So that means we have to find out where x squared minus 1 would equal 0. Let's factor this out. So it'd be x minus 1, x plus 1 equal to 0. Now let's apply this. So it'd be x minus 1 equals 0 and x plus 1 equals 0. It would be x equals to 1 and x equals to negative 1. Since x equals 1 and x equals negative 1 makes the denominator 0, these values are not included in the domain. Therefore, the domain of fx consists of all real numbers except x equals to 1 and x equals to negative 1. So this is our last problem of today. Let's look at the function fx equals x squared over root 6 minus x. And we have to determine the set of all possible x values that make this function well defined, which is finding the domain. This function involves a square root in the denominator. Remember, the expression under square root must be a non-negative, meaning it cannot be negative, and denominator itself cannot be 0, as division by 0 is undefined. So that means it has to equal, or it has to be 6 minus x greater than or equal to 0 for the definition of a square root, which would equal to x being less than or equal to 6. However, we also need to make sure the 6 minus x is not 0 because it's in the denominator for a rational function definition. So that means we have to remove the equal to sign. So it just become x less than 6. So x must be less than 6, but can be any number up to, but not including 6. This is to keep 6 minus x positive and avoid division by 0. So for interval notation, this would be left as infinity, comma, 0, 6, and it would be parentheses because it cannot equal 6. So we found the domain of this function, x squared over root 6 minus x. Thank you for watching this video, and like and subscribe if you want more tips and tutorials for precalculus.